All right, buckle up, everyone, because today we are diving deep into the heart of Java.
That's right.
How those programs you write actually come to life.
We're going beyond just the code itself.
Right.
Think of it like
Yeah.
peeking behind the curtain of a magic show to see the mechanics underneath.
I love that.
Yeah.
We've got some fascinating excerpts here that delve into the Java virtual machine, the JVM.
Right.
And I'm particularly excited to unpack some of those common Java keywords
Yes.
that, let's be honest,
Yeah.
can feel a bit like secret handshakes if you don't know the meaning behind them.
By the end of this deep dive,
Yes.
you'll be able to picture what's actually happening when your Java code runs.
Okay.
And why those keywords are so crucial.
Now, the source material uses a car program as an analogy to illustrate the fundamentals.
Right.
But let's push that analogy a bit further.
Okay.
Imagine you're not just building a car.
Yeah.
You're building a self-driving car.
That's a great way to think about it because it introduces the complexity of the JVM.
Yeah.
It's not just assembling parts, it's coordinating a complex system.
Exactly. So picture the JVM as the brain behind this self-driving car.
Okay.
Our car class is the blueprint, but the JVM is the one reading the blueprint, understanding the instructions, and making sure everything works together seamlessly.
Right, and just like our self-driving car needs a starting point, the JVM needs a place to begin executing the code.
Okay.
That's where the main method comes in. It's the ignition switch.
Yeah.
It kicks off the whole process.
Okay, that makes sense.
Yeah.
But the source also mentions that the main method has to be static. Right. Now, I know static means something about being shared, but why is that so important for the main method specifically?
That's a great question, and it gets to the heart of how the JVM works.
Okay.
Remember, the JVM needs to be able to run your program before any objects are even created. If the main method wasn't static, it would be tied to a specific object, which wouldn't exist yet.
Ah, I see. It's like needing the car's computer to be running before you can even start building the rest of the car.
Exactly.
It has to exist independently.
Precisely. And once the JVM has found that static main method, it can start loading the class,
Okay.
which is like setting up the assembly line based on the blueprint.
So we've got our blueprint, our assembly line, and our ignition switch.
Yes.
But where do all the parts of our self-driving car, the objects, the methods, the data, actually reside?
That's where memory management comes in.
Okay.
And this is where the JVM really shows its smarts.
Right.
It organizes memory into distinct areas, kind of like a well-organized warehouse.
The source mentions a static area,
Yeah.
which we've already touched on a bit.
Uh-huh.
It's where shared resources live.
Yes.
In our self-driving car analogy, it's like the central computer system that all the car's components rely on.
And then there's the heap. This is the vast space where all those unique objects are actually created.
Right.
It's dynamic, constantly changing as your program runs.
So if the static area is the central computer,
Yeah.
the heap is where we're building all the individual sensors, cameras, and actuators that make our cars self-driving.
Exactly.
Gotcha.
But there's one more crucial piece, the stack.
Okay.
This is where the JVM manages the execution of methods and keeps track of references to those objects in the heap.
Okay, so the stack is like the control center that's orchestrating the whole assembly process.
Right.
Making sure everything happens in the right order.
Right. Now, understanding how these different memory areas work together is crucial for efficient Java development.
Okay.
Think about it. If you know how the JVM manages memory,
Yeah.
you can write code that minimizes unnecessary object creation, reducing overhead and making your programs run faster.
So it's not just about writing code that works.
Yeah.
It's about writing code that works well with the JVM, optimizing for performance.
And that's one of the key benefits of understanding what's happening under the hood.
This is already blowing my mind.
Yeah.
We've got this intricate system of memory management and code execution happening behind the scenes, and we're just getting started. Okay, so we've laid the groundwork with the JVM and memory management, but what about those Java keywords we talked about? They're like the tools that let us interact with this whole system.
Absolutely. Our source material focuses on a handful of them. This static main public class and the dot operator.
Right.
Each one plays a critical role in how we structure and control our Java programs.
Let's start with this.
Okay.
Because the source mentions it's all about referring to specific instances of variables. But honestly, that explanation still feels a bit fuzzy to me.
Well, think about our self-driving car again. Each car has its own unique set of properties, right?
Yes.
Its color, its mileage, the current speed it's traveling at.
Right.
These properties are all variables within the car object.
Right, so we could have multiple car objects,
Mhm.
each with its own speed variable, for example.
Exactly. Now imagine you have a method within the car class that needs to access the speed variable for that specific car.
Okay.
How does it know which speed variable to use? That's where this comes in.
So this is like saying, hey, I'm talking about the speed variable belonging to this particular car, not any other car.
Precisely. It's a way to disambiguate when you have multiple instances of the same variable within a program.
Okay, that makes a lot more sense now.
Yeah.
It's like each car having its own internal dashboard, and this is how it refers to the gauges on its own dashboard.
That's a great analogy.
Yeah.
Now let's shift gears to static.
Okay.
We briefly touched on this with the static area of memory, but it's also a keyword we can use when defining variables and methods.
And if I remember correctly, static means something is shared across all instances of a class. But why would we want to do that? What's the advantage?
Well, let's say in our self-driving car program, we want to keep track of the total number of cars that have been created.
Right.
This isn't a property of any individual car. It's a property of the entire car class.
So we wouldn't want each car object to have its own separate count.
Right.
We need a central tally.
Exactly. And that's where static comes in.
Okay.
By declaring a variable as static, we're saying it belongs to the class itself, not to any specific object.
Right.
All car objects can access and modify this shared variable.
So it's like having a central database that all the cars can connect to and update.
Precisely. And this can be incredibly useful for things like maintaining global counters, tracking system-wide settings, or storing data that needs to be accessed by all instances of a class.
And speaking of accessing things,
Yes.
we've also got the public keyword.
Right.
I know this has something to do with making parts of our code accessible from other parts of the program, but
Yeah.
could you elaborate on that?
Of course, in Java, we often want to control which parts of our code can be accessed and modified from the outside.
Right.
It's all about encapsulation, protecting data, and ensuring that objects are used in the way they were designed.
So it's like having security protocols in our self-driving car system, preventing unauthorized access to sensitive components.
That's a great way to think about it. Now, the public keyword is like giving something a public-facing API. It says, hey, anyone can interact with this method or variable.
So it's like the steering wheel or the gas pedal parts of the car that are designed to be used by the driver.
Exactly. But there are also other access modifiers like private and protected,
Right.
which restrict access to certain parts of the code.
Okay.
It's all about creating a well-defined interface and maintaining the integrity of our objects.
Okay. I'm starting to see how these keywords give us fine-grained control over how our programs are structured and how different parts interact.
And that's one of the things that makes Java such a powerful and versatile language.
So we've covered this, static and public.
Right.
What about the dot operator? It seems so simple, just a little period, but I have a feeling it's more significant than it looks.
You're absolutely right. The dot operator is fundamental to how we interact with objects in Java.
Okay.
Think of it as the bridge that connects our code to the specific data and behaviors encapsulated within an object.
Like a remote control for our self-driving car.
Exactly.
It lets us send commands and access information.
Exactly. Let's say we have a car object named mycar.
Okay.
Using the dot operator, we can access its methods,
Uh-huh.
like mycar.startEngine or mycar.accelerate.
Right.
We can also access its variables, like mycar.speed or mycar.color.
So it's the key that unlocks all the functionality and data stored within an object.
Precisely. It allows us to manipulate objects, retrieve information, and trigger actions, making our code dynamic and interactive. And that's really the essence of object-oriented programming in Java.
Wow. It's amazing how these seemingly small keywords and symbols play such a massive role in shaping how our Java programs work.
Right.
It's like they're the building blocks of the language itself.
And once you understand these building blocks, you can start to see the bigger picture,
Yeah.
the elegance and power of Java's design.
Yeah.
You can write code that is not only functional, but also well-structured, efficient, and maintainable.
I'm already feeling like I have much deeper appreciation for the intricacies of Java.
And we're just scratching the surface.
Right.
Before we go any further,
Yes.
there's one more keyword we need to talk about: class.
Okay.
It's the foundation of everything we've been discussing.
Okay. Class. It feels like we've been dancing around this one all along.
All right.
We've talked about the car class as a blueprint,
Yeah.
but I'm ready to go deeper. What exactly is a class in Java?
It's a great point to pause on because Class is truly the heart of Java's object-oriented approach.
Okay.
Think of a class as a template, a
Right.
mold.
Okay.
It defines the structure and behavior that all objects of that type will share.
So in our self-driving car analogy, the car class is like the master plan that outlines what every self-driving car should be capable of.
Exactly. It defines the properties, like color, speed, model,
Right.
but it also defines the actions, the methods, like start engine, accelerate, brake.
Mm-hmm.
Each individual car object will have its own specific values for those properties,
Right.
but they all follow the same blueprint.
That's starting to click for me. So each car object is like a unique instance of that car class,
Precisely.
inheriting its structure and behavior.
Precisely. And that's the beauty of object-oriented programming.
Yeah.
We can create these reusable templates,
Right.
these classes,
Okay.
and then instantiate them to create as many objects as we need.
Okay, so the class keyword is how we actually define these templates in our code.
Yes.
But earlier you mentioned constructors.
Yeah.
Where do they fit into this?
Constructors are special methods within a class
Okay.
that are responsible for initializing objects when they're created.
Uh-huh.
It's like the assembly line workers in our factory,
Yeah.
making sure each car has its engine installed, its wheels attached, and its software loaded.
So the constructor is what takes that blueprint from the car class and actually builds a functional object based on it.
Exactly. And this brings us back to an interesting point our sources raised.
Yeah.
Alternative ways to initialize objects.
Okay.
While constructors are generally preferred,
Right.
it's technically possible to use setter methods instead.
You mean instead of setting the initial values for things like color or speed within the constructor, we could create separate methods to set them later on?
Precisely. But this approach can lead to more verbose and potentially less reliable code.
Right.
Constructors provide a centralized and efficient way to ensure objects are properly initialized from the get-go.
It's like trying to build a car piecemeal, adding the engine after it's already rolled off the assembly line.
Exactly.
Yeah.
It can be done, but it's not ideal.
Yeah.
Constructors streamline the process and ensure consistency.
This has been an incredible deep dive. I feel like I've gained a whole new level of understanding of how Java works. It's not just about memorizing syntax. It's about understanding the elegant design principles behind the language.
And that's what makes a deep dive like this so valuable.
Yeah.
It's about connecting the dots, seeing how each concept relates to the bigger picture.
Right.
It's about appreciating the thought and ingenuity that went into creating a language as powerful and flexible as Java.
I'm definitely feeling a bit mind-blown by all the intricate mechanisms happening behind even the simplest Java program.
It is quite remarkable when you think about it. But here's a thought to leave you with.
Okay.
We've talked about constructors and how they initialize objects.
Right.
But what about the scenarios where we don't define a constructor?
Yeah.
What happens then? That's a little mystery for you to unravel on your own.
Ooh, that's a good one.
Yeah.
It just goes to show there's always more to learn.
Right.
Always another layer to uncover.
So, to our listeners, we encourage you to keep exploring, keep experimenting, and keep that curiosity alive. This deep dive has given you a glimpse into the inner workings of Java.
Yeah.
But the journey doesn't end here. There's a whole world of Java knowledge out there waiting to be discovered.
And who knows, maybe your next deep dives will lead you to uncover some hidden gems that even we haven't stumbled upon yet. Until then, happy coding, everyone.